What's going on, friends? Sam Prentice back once again. This is part 3 of the Tiny Bike video, and we're focusing this time on electronics. Apologies that it's taken such a long time to get this video out. And of course, 3D Printopia has been and gone. So we're going to be focusing on the next couple of shows that are going to be coming up in the new year. And of course, towards the end of this year, which is the Sanjay Mortimer Retro Festival up in Manchester. What will happen towards the end of this video is we put a collage of all 3 elements together, and then we'll release this to the general public, so people will be building this on their masses we would expect. Let's get straight on into it, shall we? Here we go.
You are watching a master at work.
The 3D printed Tiny Bike? Tomorrow is here today with this luxurious design. Compact, foldable, and easy to assemble, this bike rides like a dream come true. Crafted from high-quality, durable materials, it's not just an eco-friendly transportation solution, but also a stylish statement. Whether you're commuting through the city streets or enjoying a leisurely ride in the park, this tiny wonder fits perfectly into any lifestyle.
I realized, ultimately, I didn't have a filament right.
Again?
Yes, that's right. Wait,
I need your clothes, your boots, and your tiny bike.
the tiny bike, you know you can 3D print these things, right?
Yeah, I heard the Push XL's pretty cool.
Yeah, but probably make a filament.
All the electronic components will be inside what we call the potty. By now you should have the motor, gearbox and adapter installed onto the bike, and hopefully you'll be ready to install the cables. We're currently working with Rev Robotics and their lineup, and using 2 ESCs, namely the Spark Max. I used some Velcro strips to hold on the ESCs and the batteries to keep them in place. On the Spark Max there are a number of connections that will need to be made. The 3 cables, red, white and black, will connect to each of your motors, while the red and black on the top will connect to your battery. The battery that I'm using here is a 14.8 volt LiPo rated at 6500 mAh. These are flight compatible as they are under 100. This battery is terminated with an XT90 connection. I then line up the parts to make sure that all the cables are going to reach. On the motor connections, I add some Wago connectors. This makes it really easy to strip down if needed in the future or to swap out parts. I take the ends off the silicon and plug them into the Wago. You should end up with something like this. My usual process for this is strip the cables and, well, just twist them before plugging them in. I do the same on the other side. On each of the motors, you'll see a connector that will need to be plugged into the ESC. This should be pretty straightforward as to where they plug into.
I'm Ryan Reed with Offset Maker Lab, back with another edition of Just the Tip, here to provide timely advice for your Print My Ride project. Now, over to Stephen in the lab for a tip on making electrical connections. Stephen?
Okay, so it's really important that you make sure that you get the right wires hooked up to the right things and you solder things correctly if you solder them, because if you don't, bad things.
Thank you, Stephen. Remember, it is important to keep the magic smoke inside your components at all times. Back to you, Sam.
Thanks, Ryan. As I was about to say, things do start looking a little bit more complicated. So the wiring diagram hopefully should look a little bit like this. At the very top we have our LiPo battery. Again, it's a 14.8 volt battery with a capacity of 6500. The positive and negative cables are split with an XT90 with tails connector. These go into a 5-way Wago block. The positives of both the ESCs will plug into the corresponding block, red and black. We will then also introduce a voltage regulator that takes our 14 volt down to 5 volt. This is there because we need to add power to the servo controller, so pay attention as to where you plug this into on the servo controller, as one side is for input power, the other is for the 2 cables to route back to the ESCs, so in total you'll have 3 JR cables plugging into that servo. On the 5 volt reducer, typically the color for the positive and negative out on the 5 volt will change from red to yellow. You can use a small Wago connector to connect this to the JR cable just to route back to the servo controller. The 2 JR cables out of the servo controller will then plug into each of your ESCs. It's at this point typically I'd like to try and see if the power works to the ESCs, and they do. The Rev Robotics ESCs are programmable, and you can connect to them via the orange USB cable that's provided. You can set things like ramping speed, introducing dead spots to the servo controller, and adding braking, and much more. You'll need to do this using a computer that runs Windows to install their client software. In doing so, you might be asked also to upgrade the ESC, and I would suggest you do that. Inside the software though, the key area that I want to focus on is reversing one of the motors. And if you run a test on your servo controller, you'll probably see that one of the motors will spin incorrectly the wrong way. So we need to invert that motor.
Hello. Today we are going to program the ESCs for the Rev Robotics motors in the Tiny Bike projects. First thing you need to do is make sure that your wiring is completed and the ESCs and everything is plugged in. I've gone ahead and hooked up these control wires to the ESCs in advance so that we can just plug them in. Turn your power on, making sure that the ESCs are lit up. There's 2 indicator lights on them. That's what you need to light up. Then you take your cable and plug them into the computer. It already comes up showing you the SparkMax. Now this is not up to date. We have to update the software prior to doing anything with it. So if your software isn't already downloaded, it will download it and then you can update. Before we go any further with that, just to make you aware, these things will need to rotate. So we bridge up the bikes so that the wheels aren't on the ground, so that when we rotate them and check rotations, it won't take off on you. Okay, now after the update is complete, a lot of times it says no hardware detected. So you can scan for new devices, it'll force it. Sometimes we'll have to unplug and replug in for the CAN bus to show up, which I think is what's gonna happen here.
Close the whole program down.
Yeah, and reopen. There we go, perfect. Now we have the CAN ID. We'll go into the controller. You'll notice that it says non-configured. So what we need to do is we need to give it an ID number so that we know what motor is what if you ever go back into it. So right now we're just gonna go 1. Shows our input voltage. Once this is done, we can burn flash. Yes. Now it's configured. So after this is done, we're gonna go over here to advanced. Going to basic. You can see you are number 1. You can see it's on coast. And then this is your inverted button. So this is where you're gonna go to swap directions between left and right side. So in order to know which side is facing the correct direction, you're gonna come over here on the selector to run. You're gonna go run motor, and then you're gonna slide this bar. So obviously positive is forward, negative is reverse. This wheel is turning in the correct orientation.
And just a word of warning
both.
around the smoke.
So
If you don't use the right
this one
cables,
is now
well,
complete.
this is the
You
result.
don't have to
that
do
could
anything more
possibly
here
happen,
at this
and
time.
might burn
It will
your
run
bum.
as it should. So we're going to stop motor. Go back to basic. This is all set. Now we can X out of this. Disconnect this guy. Now you're going to plug in your other ESC. Here it comes up. See how we have CAN ID 0, not configured. Let's go 1. Now it's number 2. And then we are going to come over to advanced. This one will have to be inverted. So you're just going to select the slider and then burn flash. It is now complete. We can come over to run. We're going to activate the motor, and then positive is now spinning the correct direction. And that's it. Thank you, and have a good day.
So hopefully that goes some way to helping you out in regards to your tiny bike project. There is one thing I do want to point out, and that's on the cabling side. You're definitely going to be wanting to make sure you're using 12 gauge cable, which is shown here. And just a word of warning around the smoke, if you don't use the right cables, well, this is the result that could possibly happen, and it might burn your bum. I guess in closing, have fun, be safe, look out for others, and we take no responsibilities for accidents or injuries, but we can all agree that scars do certainly look cool.
That's scary fast, isn't it? But he wants to do it again.
You are watching a master at work.